So first of all, my name is Jorgen Qvist. I have a daytime job being the operating officer for NORDUnet, which is completely uninteresting in this context. So what I'll try to do is see if I can tell you something about Polar Connect in less than 20 minutes. So let's see how that works. First of all, what is a subsea cable? Well, it consists of a few things, and it's not as big as you believe. I have here a sample of what's a double armored subsea cable that you see many of around. This could be transatlantic, could be anything, but this is about what we're talking about. It's quite vulnerable, and this kind of takes us to the next slide, that things are getting problematic in view of the situation we have. This picture here is taken from when Nord Stream 2, the gas pipe, was blown up. It's taken just above as all the nice gas is exploding into orbit. And since then, what we have seen is that specifically in the Baltic, there have recently been a lot of situations where there's been a new sports where carriers forget to take up their anchor and then they just sails across areas where there are multiple subsea cable systems, which have caused quite a few damages to cable systems in the Baltic area. And you want to look up something really funny in that, look and try to Google for Svalbard cable damage. There's some funny thing in the public domain and even more funny thing that's not the public domain. But then again, this all leads to that, what do you do? I mean, you can't really prevent people from damaging subsea cables. They're easy to damage, far too easy. So what you need to do to make sure that you still have connectivity and keep the internet alive, endless amounts of cat videos needs to be available. You have to build redundancy. You have to have multiple cable systems, and you need to have lots of them because, as I said, it's fragile. That is what you're also seeing a lot of the big OTTs doing. They're also building multiple cable systems to the same locations. And it's just something you need to do. And as Sebastiano hinted, it's maybe a little bit more difficult for us to do it because not all the cable systems is commercially available. So it is a concern for the ones of us who doesn't have an endless amount of money in the bank, that we keep having the options to actually have a redundant network. The good thing is that the EU is also aware of this. So they have created some programs. This is one of them that we are particularly interested in, this Global Gateway program, where the one that we specifically are interested in is the Arctic part of it. And as you also see in all of the slides, there is a small EU logo in the bottom because what we do has been co-funded by the Commission. And we will require even more co-funding to actually get the cable built. So what are the problem space that we are looking at from a European perspective? Well, from a European perspective, there is a couple of continents we want to connect to. One is the North America, South America, that whole continent. That is actually, if you look at it today, due to a lot of different things, that is actually well populated. There's many cable systems to choose from, and there's actually a large degree of redundancy and geographical spread. So that's actually not a huge problem space. The problem space, if you look between Europe and Asia, there used to be a couple of options available. One of them was to Russia. I don't think there's any contracts left that I'm aware of that's still live on that cable routes. There's a lot of cable that all goes through the Suez, roughly 7, 8, depending on how you count them. But they're all inside 1 square meter or square kilometer at a certain point in time. And it was actually when the Houthis it's actually sunk a ship there, and that ship managed to damage 3 cables at the same time. And these have not actually been truly repaired. So there's actually parts of those systems that are still not up and probably not will be up for a foreseeable future because you can't get someone with a cable repair ship to go there. It's simply too dangerous. There are other cable systems that are less modern and less capacity that's also traversing other areas that is basically not available at the moment due to the geopolitical situation. So that basically means that the connectivity between Europe and Asia is at great threat. It has actually been so for quite many years, and it's definitely become worse given the global situation. So back in, was it 2016, 17, we started working on this project about actually creating connectivity between Northern Europe and Asia, specifically Japan, over the Arctic basin. That was one of the things we started working on. We had a nice report written. Got a really good documentation for this is a really good idea. It's available online if you want to read it. So that's basically what we started working with. There are in the moment 2 parallel projects that are trying to solve the same problem. We are working together to not step on each other's toes. So that's the Far North Fibre, which is the southern route. And then the thing we are working on, which is the green route up there called Polar Connect, which is the one that's going really close to the North Pole. So this is basically the 2 projects that's trying to solve the problem. We are working together. We do believe that we will need more than one cable to have redundancy because there are issues with cable repairs getting to the cables at parts of the year, and that's just true for both of the routes. So we do believe that we need each other as a system to make things work. Benefits, yeah, nice graphics. As I said, it's unexplored, being there's no other cables that traverses the northern route at all. There is a cable system that traverses parts of the southern routes, but and it's by a company called Quintillion, which have had serious problems with their repairs in the area. So it is a concern to actually get to the cables when there is ice and icebergs and other nasty things that prevents you. That's about the good thing it says about the northern route. Once it's there, it's actually quite safe because it's under the ice. And it's hard to get to. I mean, if it's hard for you to get to, also means it's hard for other people to get to. So in that respect, once the cable is there, ice is your friend. It doesn't harm you because there's somewhere between 4,000 to 2,000 meters depth under the ice. So it's a fairly safe place to be. And again, endless amount of benefits that you can read about if you care. But it's really important that this is the type of benefits we are looking at from a European perspective. It's not just because it happens to go from Norway to Japan that it's really good for these 2 countries. No, it's really good for Europe because that provides the redundancy for Europe that is needed between Europe and Asia. I showed you a picture of a nice report with a lot of good benefits. There are benefits for the Nordic region. There are benefits for all regions that gets international connectivity. But specifically for the Nordics, there's a lot of good benefits because it's really beneficial where you put your really power-hungry data centers up in the north where there's free power, mainly water. It's nice and easy to cool. You just open your windows, have a few fans, and it's all working nicely. And again, it's a lot cheaper to transport the data than it is to actually transport the power that you actually create up there. So lots of really, really good reasons why you should do it. And actually, there's a lot of the big OTTs and others that have power-hungry systems that's already doing it. So it's something that's accelerating. I think it's something that we will see because there are certain things where you want the data centers closer to your customer, especially if you're talking real-time communication. But nowadays, where everyone is talking AI, it's like born for it. It's not really latency sensitive. So it's really, really favorable to put your data centers and really compute-intensive stuff up north because it's simply cheaper. Because electricity is cheap, cooling is more or less for free. So it's something we expect to see a growing trend. And yes, that will help the region if you have connectivity to elsewhere in the world where they have the same problem. And then there's the climate. Yeah, I'm not going to pretend I can save the world or anything else of that, but there's two specific things that are interesting, and it's also going to affect especially Northern Europe. Sea level rising, yes, that affects everything. The other thing that we all need to think about and think hard about, because that's where the scientists is not necessarily agreeing. So ocean heat circulation, one of the major problems that we might face is that the Gulf Stream and the AMOC, as it's called down below, is actually, if that is slowing down, we will all not be having nice warm summers, but we will having ice year round, all the way down to around like London and Copenhagen. So a little ice age might be on the way. It's not going to stop global warming. It's just that it will have an adverse effect on the northern half of the globe. But you might be surprised. A little bit of technical stuff, Luciana. So what we see is that it's under the ice, yes. It's deep, it's all that good stuff. And we're not completely starting from scratch, even though there's a lot of ice there. There has been expeditions, there have been exploration of the seabed, so we know roughly what it looks like. There's more that needs to get done before you can actually lay a cable there. So that's kind of, it's work in progress. And what's what the whole project is on for the next 3 years. I try to put the thing with the icebreaker at the back end of the presentation, because typically people get hung on that. So to actually deploy a cable going north of Greenland, somewhere between there and the North Pole, you need 3 icebreakers: a big heavy icebreaker, a kind of smaller icebreaker, and then a reinforced cable laying ship. That's what you need. The picture on the left is from a drilling expedition that they did 3-4 years ago. And the top right picture is from the existing icebreaker called Oden, the Swedish icebreaker. And the lower picture is the icebreaker that Sweden is going to be built, that we actually is going to need as the big heavy icebreaker. So the big heavy icebreaker that you see on the front, or the big picture, is actually Russian. There are 5 icebreakers that have the capability to do that, where you can just go in a straight line across. They're all Russian and they're all nuclear powered, and they are, by the way, all unavailable to the market currently. So again, a new icebreaker is needed that has the right capabilities. Hopefully in the making. The financing for doing expeditions the next 3 years is done, so we will have mapped all of the seabed that we need to have mapped by 27. And that is also when there needs to be a go, no-go decision for actually building the cable. So we need a lot of financing in place by then. As we are from an NREN world, we also care about science. So we have already from day one involved our scientists in this. So we have several workshops where we have tried to figure out what is the most important for them, because you can deploy sensor technology unless the cables can do something by themselves. Not talking dual-use technology or multi-purpose technologies or anything else you want to talk about. That could be super interesting, because that's a whole talk in itself. But what we learned is that the scientists' top priority is, luckily enough, under the ice, because they can't get to it at the moment. You can't go out and throw bories in and pick them up the year after, because it will all be ice. So it's where there's nothing there under the ice, and that conveniently enough is also in waters where there's no jurisdiction, so you don't really need to ask too many people about what you deploy there. So you can actually deploy sensors, not very sensitive sensors, but you can deploy stuff that will help you with temperature, salinity, the type of things that is important for environmental things. So that is what we plan to do currently, to only deploy sensors in that area. So nothing in Norwegian waters, nothing in US waters. So yeah, again, it is to support a range of science areas, but as you see at the bottom, also very importantly, it's also to provide connectivity for all of the science that is not part of actually using the sensors. So in summary, this is what it's all about. We will get there, but there is a serious pot of money needs to be found, but there we are mainly looking to the Commission and to some of the governments involved, because there is a high interest. I don't believe that this will ever be a fully commercial cable. It will need public funding to be built. Once it's built, yes, you can have commercial companies buying in on fibers or capacity, but you need public funding to get it built simply due to the risks. Because it's not been done before, a lot of the commercial players take a step back and don't dare to do it. And again, if you would care to read more, there's a website, there's some reports that you could read. There's loads of information that's available to you.